This video was produced by the UCD Maths Support Centre in conjunction with the UCD Access Centre. What is expected value? The expected value of a random variable is the long-run average of the experiment it represents. For example, the expected value of a 6-sided die roll is 3.5, i.e., if we add up all our die rolls and divide by the number of rolls, this would give us 3.5. The expected value does not need to be one of the outcomes of the experiment. As we know, it is impossible to roll 3.5 on a die. Going back to our definition for expected value. The expected value of a random variable. What is a random variable then? A random variable is the set of possible values or outcomes from an experiment. In our die example, the set of possible outcomes was 1, 2, 3, 4, 5, and 6, i.e., what side of the die is facing up. This is linked with sample spaces. In regards to a tossed coin, we could say that the random variable is the number of heads when we toss a coin 5 times. In that case, it'd be 0 through 5. There is a formula we can use for the expected value of a random variable x. We call this E bracket x, the expected value of a random variable x. And this is equal to the sum of x multiplied by the probability of x. This formula should become clear as we work through an example, which we will do now. The question states that in each game, a player spins an arrow and wins the amount the arrow lands on. In each game, all sectors are equally likely. Calculate the expected value of both games. I'm going to use a table to calculate the expected value of game A. Looking at the table, the first line is outcome, our random variable. For game A, we have outcome of €0, the outcome of €1, €4, and €7. And I'm just reading this from the spinner. The next line of the table is the probability, Px. So the first one is the probability we'll get €0. We know that the probability is equal to the total number of successful outcomes over the total number of outcomes. So in this case, we can land on 0 in one sector only, and there is 5 sectors in game A. For €1, we can land on it in 2 sectors. So the probability in this case is 2/5, and working our way through, we have a 1/5 and a 1/5. Next thing we need to do is multiply our outcome by the probability. So 0 times anything will give us 0. Next is €1 multiplied by 2/5. This will give us 40 cents, or 0.4 of a euro. €4 multiplied by 1/5 will give us 0.8. And €7 by 1/5 will give us €1.4. Looking at the formula, we have multiplied x, the outcome, by the probability of the outcome. According to this formula, we need to add up all the values of x multiplied by px. So adding up 0 plus 0.4 plus 0.8 plus 1.4 will give us 2.6. So the expected value of x for game A is equal to 2.6. Now we'll move on to the expected value of game B. For game B, we will not use a table. Instead, we will follow the formula. The expected value of x for game B is equal to x times the probability of x. We'll take 0 as our first x. So starting off, we have 0 multiplied by the probability of 0, which is 1/6, as this time we have 6 sectors and 1 sector where 0 is. I'm putting brackets around that to make sure I do multiplication before addition. And the formula says to add up the next variable multiplied by the probability. So we'll take 1 as our next x, multiplied by 2/6, as this time there's 2 sectors where 1 appears. Our next x is €3. This is multiplied by a sixth. And we keep going through all the possible outcomes. Adding this up, we'll get 0 by a sixth is 0, plus €1 by 2/6 is 2/6 of a euro, plus €3 by a sixth is half a euro, and so on. Summing this up, we will get our expected value equal to 2.5 for game B. Now we have the expected value of game A and game B. A couple of questions about these expected values. If it costs €3 to play one of these games, would you play game A or game B, or no game? As the expected value or long run average of the games are below the cost of the games, in this case €2.6 and €2.5 are below €3, we should not play either game. In the long run, as these games cost €3, we would expect to lose money overall. If the cost of the games were only €2, we should play the games because the expected value is greater than the cost of the games. An important item to note is a game is fair if the expected value of the game less the cost of the game is equal to 0, or the expected value overall is 0. In this case, as our expected value of the games less the cost of the game, so in game A, €2.6 minus €3 is not equal to 0, the game is not fair. The same is true of game B. This concludes our discussion on expected value.